So this is a difficult conversion for a couple different reasons. One, because it's hard to count significant figures, and two, because you have two different units that you're trying to convert to one common unit. Okay, so a lot of times this is done in the medical field because we have pounds and ounces. So imagine, for instance, a newborn infant. Usually when they are weighed or massed, that measurement is taken in pounds and ounces, right? So what we're going to do here is we're going to try to take this pounds and ounces, this mass of this infant, and convert it to grams. So how do we do that? Well, first what we need to do is get into a common unit. So what I mean by that is let's convert this all into pounds or all into ounces. Okay, because that way, if we have just one common unit, it's going to be much easier to convert it all into grams. So what I'm going to do, my blue here, is I'm going to take this 8 pounds and I'm going to convert it to ounces. That way, once I have that 8 pounds in ounces, then I can add the remaining 8 ounces so that I have my total mass in ounces, and then I can convert that to grams. Okay, so my first step is to get this 8 pounds into ounces. So to do that, I need a conversion factor. So let's see, 1 pound is equal to 16 ounces. One-step conversion. I'm going to start with my 8 pounds. Using this conversion factor, I'm going to put pounds on bottom, ounces on top, so that pounds cancel. 8 times 16, multiplying across, gives me 128 ounces. Now, that's not the entire mass of the infant, right? Because they were 8 pounds and 8 ounces. So I need to make sure that I'm adding those extra 8 ounces to the pounds I just converted. So this is the total ounces of that infant. So this is what I'm going to start with when I'm converting. So now this problem has changed, right? It is now 136 ounces, because I have it all in the same units, and I'm going to convert that to grams. I haven't actually changed the amount. These are the same masses, it's just I have it all in one unit now. So let's approach this problem. That's going to be a little bit easier, because now I just need to find a conversion factor going from ounces to grams. So let's see, looking at all my sheets, I have one, there it is. 1 ounce is equal to 28.35 grams. So this is the conversion factor that I found on my conversion factor table going between ounces and grams. So let me go ahead and convert that. Starting with my 136. Now I use the conversion factor. I'm going to put the ounces top or bottom. On the bottom so it cancels. And then 28.35 on the top. And 36 times 28.35. So that child weighs 3,855.6 grams. But I'm not done. I need sig figs. Okay, how do I figure out sig figs? It always starts with the original number. So this is the second reason why this problem is quite difficult, is because how many sig figs do I have? I have one sig fig here for pounds, and I have one sig fig here for ounces. So in this case, since I have two different units, I need to add those together. So what that means is I have two total sig figs. 1, 2. Okay, so 2 sig figs here. That means I want 2 sig figs in my answer. 1, 2, so I'm stopping there. Look at the number next to it. Does that stay an 8? It's 5 or higher? No, it does not. It rounds up to a 9. But remember, I need placeholders. So everything before this decimal point, I'm going to need placeholders where those 2 5s are. But I need the placeholders to not be significant digits. So I'm going to place zeros there. So I went from 3,855 to 3,900. I'm sticking with my 2 significant figures, but I'm also staying at the same magnitude in the 3,000 range. So this would be the correct answer to the correct number of significant figures. Now we're going to try one where we have a cubed unit. Make it a little bit difficult, okay? So we haven't seen squared or cubed yet. So how do we approach that one? Well, for the very first part, when you're looking up a conversion factor, ignore the cubed. Okay, we need to just try to figure out how to get from a centimeter somehow to a liter, okay? So looking at conversion factors, there's one conversion factor that is not on any of your conversion factor sheets that I bring up in lab quite a bit that we use, and that is that 1 centimeter cubed is equal to 1 milliliter. Now this conversion factor is very helpful for us when we talk about density. So you'll see this a lot in density. So this is something you might want to just remember because it's very handy in a situation like this. So if I go from 1 centimeter cubed to 1 milliliter. So what that's going to do, let me write my plan here, is it's going to get me from centimeters cubed to milliliters. But I don't want to be in milliliters, I want to be in liters. So I'm going to have another step here to get to liters. Okay, so here's my first conversion factor, but I'm going to need a second to get from milliliters to liters. So this, liter, is metric to metric. I'm gonna use this guy. Since it's milli, I'm gonna go down to my prefix milli, follow it over to the liter section, and I have a conversion factor that says 1 milliliter is equal to 10 to the negative third liters. Once I have both conversion factors, I'm going to start with my original number given to me in the problem, 4730. This first conversion factor, I'm not actually changing the number at all, but I'm going to write it down since it's a 1-to-1 ratio, just so I can show that I am canceling out the centimeters cubed and I'm being left with milliliters. Okay, now the next step is to go from milliliters to liters. With this one, I want the milliliters on the bottom so that they cancel, and my 10 to the negative third on the top. So since there's only ones on the bottom, I really just need to multiply that. So 4730 times 10 to the negative third. Me 4.73 liters. How many sig figs? We got 1, 2, 3. That 0 does not count because there's no decimal point. And so I'm sticking with 3 sig figs, so we're good there. So that would be the correct answer to the correct number of sig figs. In this problem, we're going from meters squared to centimeters squared. So let's start by finding a conversion factor. Now, we don't have any conversion factors that go from meters squared to centimeters squared. So ignoring the squared portion, let's just look to see if we can find a conversion factor going from meters to centimeters. So to do that, it's metric to metric. And more specifically, we're using the prefix centi. So I'm going to go down to the prefix centi, follow it over to the meter portion. The conversion factor I find is 1 centimeter is equal to 10 to the negative 2 meters. So how am I going to use this? There's actually two different ways you can use this. So let me do the railroad tracks. Might be able to see it a little bit better. So when I start my railroad tracks, I'm approaching it the same, starting with the original number given in the problem. Now, if I use this conversion factor, I want the meters on the bottom, but notice that only cancels out one of these two. So what I need to do is I need to use this conversion factor twice. Because now I have meters times meters, so this would be meters squared on the bottom, and that will cancel out the meters squared on the top. Multiplying centimeters by centimeters gives me centimeters squared for my units. So to solve, I'm going to multiply 3.6 times 1, and I'm going to divide it by 10 to the negative 2 times 10 to the negative 2. So I get 3.6 times 10 to the 4th centimeters squared. So the other way you can do this, if you don't want to put the conversion factor there twice, is you can square the conversion factor before you use it. So what do I mean by that? Take this and square it. So when you square it, that means you need to square not only the units, but the numbers. So what I'm doing is I'm taking 1 squared centimeter squared. So 1 squared is just 1. For the second portion, I need to take 10 to the negative 2 and square it, and then take the meter portion and square it. So 10 to the negative 2 squared is 10 to the negative 4th. Meters squared is meters squared. So if you wanted to square the conversion factor first, then you can just plug in your newly squared conversion factor into the railroad tracks. You're putting the 10 to the negative 4th on the bottom, because that's the meter squared, and then the 1 on the top. So 3.6 divided by 10 to the negative 4th still gives you the same answer. Either way works.